Hello, I am Coach Meinbauer here for AP Pre-Calculus, and we are on section 2.4. Extra little part here, part 2. We're going to dive more into these exponents, and we're going to work on factoring with fractional and negative exponents. Something that's super helpful moving forward into your courses upcoming, such as calculus. So here we go. What is an expression that has fractional exponents? You can see that in example 1 right here, where we need to factor this. That's not what I wanted to do. You can see right there that x to the 1/3 plus 2x to the 3/4. Whenever we factor stuff like that, it's really just taking out the GCF and rewriting. So what we're going to do here is you find the term with the lowest exponent, and then you're going to take that out. And then you're going to rewrite the inside. You'll see what it looks like. That's kind of what this says right up here. Look for the variable exponent that is common to each term in the expression. Pull out that variable exponent, raise to the lowest power. So for this first one right here, we're just factoring. We're not solving. What is the lowest power? It's going to be x to the 1/3. So x to the 1/3 is going to come out of there. So x to the 1/3. Now, when I take out x to the 1/3 from x to the 1/3, it just leaves me with a 1 plus 2. Now we're going to subtract because since we're dividing out, that's the same thing as subtracting. So we're going to do 4/3 minus 1/3, which is going to give me 3/3, which is just 1. Okay? And that's it. You can always double check your work by multiplying through here and here just to make sure that it matches. Okay, and if you do that, it does match. Super simple. Let's get into equation. Okay, here's one where we are negative and we're fractional here. These bases now is not just a number or just a letter. These bases are an expression themselves, a linear expression, a linear factor. So I'm going to go ahead and find what's common between these two terms. So this term right here and this term right here. What is common is the x plus 2. So I'm going to take out the x plus 2. The lower power between the two of those is the negative 1/3. Leaving me with, in the first term, just a 3x is still remaining, plus what remains in the second term, the 4, and then the x plus 2 to the first power, because I'm just subtracting the negative 1/3, which is the same thing as adding 1/3. Adding 1/3 to 2/3 is 3/3, which is 1. Man, that's pretty wordy. Okay, so now all I do is just play around with this a little bit, and then we'll solve for 0. So that inside fraction there, or expression, is going to become 3x plus 4x plus 8. So this becomes 7x. So I'm going to rewrite this real quick. I'm going to make this into a fraction, because do we agree that this x plus 2 to the negative 1/3 belongs on the bottom? Yes, this belongs on the bottom. Make this a 1/3. Okay. At the top, I'm going to get 7x plus 8. Now I'm going to set this equal to 0, which means that I only care about the top. Kind of, sort of. I do want to check the domain here. I'm checking the domain. I just need to make sure that the bottom, so this is a domain issue, that x plus 2 to the 1/3 cannot equal 0, which really means that x cannot equal negative 2. So that is a solution. If I get that as a solution, I have to ignore it. Okay, so for this one right here, just look at just the top. So we're going to get 7x plus 8 equals 0. And actually, I'm going to get x equals negative 8 over 7. So that is my answer for that one, which is not negative 2, so it's good to go. Okay. Super simple. Maybe not. It takes a little bit of work. A little bit of getting used to. Number 3. This one is just a factor. Awesome. It's great. So what do these two have in common? They both have x's. The lowest power is going to be x to the negative 2. So the first term is just 3 minus 4 times x to the, now we're subtracting a negative 2. So subtracting a negative 2 would be adding 2. So this is going to be a third power right there. And again, you can always check by multiplying that back through both of those and see if it matches up, which in this case it totally does. Okay, so super simple. And then we come over here. Okay, next one right here. Wow, there's a lot going on in this problem. Do this in purple. A lot going on in this problem. It looks like I can actually factor that x cubed minus 1. I'm not going to, but it looks like I could. And I might mess around with some things. I'm going to just factor out the GCF, and I'll just go from there. So I'm going to factor out an x minus 1. The lowest power between those two is just going to be to the negative 1. Leaving me with an x cubed minus 1 minus x minus 1 all cubed. Ooh. Oh, this looks fun. We need to expand x minus 1 cubed. Luckily, we know the binomial theorem. That's Pascal. Using Pascal's triangle, we can use that for the coefficients. I'm on the third power. I'm using the coefficients 1, 3, 3, 1. So I'm going to go ahead and expand that here in just a second. This is a rewrite. X cubed minus 1 minus, and in this big old parentheses here will be our expansion using the binomial theorem. So we're going to get x cubed. We're going to be alternating signs since we're subtracting. So minus 3x squared plus 3x minus 1. How fun. Okay, so now a real quick rewrite here in this first term. X minus 1 and the negative 1. Now on the inside here, I'm going to get a x cubed cancels out with that x cubed because you're subtracting those. This negative 1 cancels out with this negative 1 again because you're subtracting those. Leaving me with this negative minus a negative 3x squared. So it's a positive 3x squared and then minus 3x. Let's do a real quick rewrite on this to make this into a fraction. So I'm going to get 3x squared minus 3x all over x minus 1. I can actually factor a little bit further. I'm going to do that. I'm going to get 3x minus, no, taking out 3x. Got ahead of myself there. 3x, and it's going to leave me with a just an x minus 1. If I'm looking at this final form here, I'm going to have a domain restriction where x cannot equal 1. Okay? So when I find and that's because my denominator cannot equal 0. So when I find my zeros, I'm going to get x equals 0 and x equals 1, but I have to reject the 1. So my final answer here is going to be x equals 0. That's all I get for that one. All right, and that wraps up. That was a totally fun, fantastic set of notes. Again, I'm Coach Meinbauer. Do not forget to like and subscribe.